I'm Nurul Hazrina binti Nordin from UMPSP STEM Lab, the Faculty of Electrical Electronics Engineering, University Malaysia Pahang Al Sultan Abdullah, the instructor for this course.
Chapter number 3 is player movement and enemy behavior. Now that we have a game window and a player, we will implement movement controls and introduce enemies. In this chapter, you will implement player control using keyboard inputs, define enemy behavior and interactions. The key programming concepts covered include control flow structures such as loop and collision, managing real-time movement, and enemy actions. This chapter adds excitement to the game by allowing player interactions and introducing challenges. Next is to set the player movement. These are the codes that would detect keyboard input and update positions of the player. This code should be inserted inside the draw player function and before draw rectangular command. A for loop is a control structure that allows you to iterate over a sequence of elements, executing a block of code for each element. For keyword initiates the loop. Element is a variable that takes on each value from the sequence. Sequence can be a list, tuple, string, or any other iterable element. This is a for loop example in Python. This is the final code of step 3. Welcome back to step 4 of our game journey. In this step, we'll delve into the world of enemies and their dynamic movements. Enemies play a crucial role in games. They introduce challenges, obstacles, and excitement. Understanding how to create and control enemy characters is a significant milestone in game development. In Python, we have a special library called random that adds a touch of unpredictability to your games. With import random, you can tap into the power of randomness. This library is your go-to for generating random numbers, making games more exciting, simulating real-world scenario, and adding an element of surprise to your Python projects. With random, you can add unpredictability to your programs, making them dynamic and engaging. Imagine creating a game where the enemy's movement or power-ups are unpredictable. That's the magic of random. Add this code below import pygame. The enemy will be represented by a red square that falls from the top of the screen. Add this code below draw player function. Let's break down the code that creates and set up our enemy. In this code, we are creating the enemy character, giving it attributes and positioning it within our game environment. First, we define the color of our enemy character. It's red in RGB format, represented by 25500. Next, we declare global variables for the enemy's position and size. These variables x_e, y_e, enemy_width, and enemy_height will be used throughout the code to control the enemy. We set the initial size of the enemy to 20 pixels, both width and height. This determines the character's dimension. Now, let's talk about enemy's position. We use random, rand_it, 0, width minus enemy width to set up the initial x coordinate. This places the enemy randomly within the game width, ensuring it doesn't go beyond the screen. Finally, we set the initial y coordinate of the enemy to 0. This means the enemy starts at the top of the screen. As the game progresses, we'll update the coordinate to make the enemy move downwards. Remember, this is pixel coordinate. With these initial attributes and positions, our enemy character is ready to take its place in the game world. Stay tuned as we bring the enemy to life with dynamic movements in the next steps. Let's dive into the details of this function. First, we access global variables that we previously defined. This includes the enemy's position, dimensions, the game's width and height, and the enemy's object. We create the enemy character using pyGameRect, a function that represents a rectangle. A rectangle serves as our enemy character. Now, let's animate the enemy's movement. We check if the enemy's Y coordinate is within the screen height. If so, we move the enemy 5 pixels down. If the enemy goes off the screen, we reset its position. The Y coordinate is set to 0, positioning it at the top of the screen, while the X coordinate is randomly chosen, allowing the enemy to reappear at different horizontal positions. The final step is to draw the enemy on the screen using pyGameDrawRect. This function paints the enemy rectangle with the red color we defined earlier. With the draw enemy function in place, we are now able to see our enemy character in action, moving down the screen. Stay tuned as we continue to add exciting features to our game. Now that we have defined the draw enemy function and set up our game environment, it's time to introduce our enemy character to the game loop. In this step, marked as 4.4, we seamlessly integrate the drawing enemy function into our game loop. In step 1.6 before, we begin by filling the game screen with background color. This clears the previous frame, preparing the canvas for our next move. As we are creating a complete game experience, we continue to draw our player characters on the screen using draw player function in step 2.3. Now, the exciting part of step 4.4. We call the draw enemy function right here within our game loop. This is where our enemy character with its defined color and movements come into play. To ensure the game runs at a manageable pace, we have added a small delay using pygame.time.delay50. This controls the speed of the game, allowing for smoother gameplay. This is how the initial code looks like. Now, make the enemy into a circle. Feel free to explore Pygame library at the pygame.org.